patients.
Right.
Um,
Is there a way to use
Flow,
those?
or gene ontology. Oh, sorry. So here's
Right. See, right on top is cellular response.
pathways involved.
See, the top one is what we.
Yeah.
Wait,
Oh.
in.
He's in and out.
You guys are breaking up a little bit, but can you hear me?
Yes,
Yeah.
we can. Ian, sorry, quick question. Can you demonstrate how you? I mean, do you have to have a special program to do this gene ontology?
So the gene ontology, the way I used it just now, it is just taking their entire gene set library, comparing it against this gene set, coming from differential expression between the two.
Okay.
How did you do that? Did you copy that gene set into something?
So we have this. Yeah, you can actually. We have a link through our doc
Yeah.
analysis
Uh-huh.
right to ontology.
Oh, okay. Yeah, I see human GO there. So,
Yeah, it's just that's just something I have on my desktop here. So gene set libraries. These are all just GMT files.
Okay.
I downloaded these. Some of these were downloaded from different databases, like KEGG or Geo. But we also have like PMCs developed in house. These PDMC gene sets are meant to describe the different types of PDMCs that we were looking at in like AppSeq and SiteSeq. But that's just one example, right? You guys might have actually, some inside knowledge on what the best gene set libraries would be in terms of, exploring these gene sets for your purposes.
well, I think Binga was saying, how did you do that so quick? I'm wondering too. Here's your set of genes, and then what did you do to get from there to there? Did you click on? What did you do? There's your gene. There's your gene
Let me
set.
show you. So I figured we have enough genes.
Right.
Genes. So this
Right.
would be like what I call the discovery gene set.
Right.
And if I right click on that, you'll see you get a few different gene view graph window. I can export it, but I can also go to enrichment text
Yeah.
information. The model here is going to be the total universe of possible genes, and so for that I'm going to utilize the concatenated file itself. And so that's going to contain something like 25,000 genes. And then I set a p-value cutoff, so the amount of significance that I require in order to be listed in the table. And then I can choose any gene set library I want to do. And a gene set library is a gene matrix transpose file that just contains a list, a collection of different gene sets.
Right.
So we already tried Go, we might try something else.
Well, Go
we
is
can try my
Go is good.
out. In fact, we can do all of the cell subsets and see if anything matches. And it looks like nothing matches.
Go.
So you can,
That is a good list right there. That's a good list because that's consistent with what we know. The interferon is up in top and the interferon response, and that's a hello.
Yep.
Can you go with that
This is a
list?
great list.
We've seen that list before, response to virus, etc. So that's a perfect list.
Okay.
So however you got that, we're looking at the right list. Can you? I'm trying to keep getting back to the answer. Can you find cells that have those properties, and in 165? I guess you do have those cells, right? Have the highest level of those properties somehow, and then you want to look at the VDJ for those. How many cells is that in this list? How many cells did you?
So Yeah, so this is not a list of cells. These are gene sets that match
Right.
with the gene set for the cells that were
Right.
in sample 165 and B cells.
Right.
Relative to 160.
Can you? So we want to get.
36 gene cells. So 36 genes.
So there are 30. Yeah. So there are 36 cells that did this.
Genes, 37 genes.
Oh, 37. Okay. So do you know?
Right.
Do you know which
Exactly.
cells fit those properties the best? In 165.
Well, there's something about 165 relative to 166 that
Right.
seems to have these properties. I would say.
Right.
Well, I see every time we lost his voice.
Right. Those are the properties. That's exactly it. Yeah, you see virus response, everything. No, we want.
His voice.
I want cells with those properties, and I want about 20 of them. Right.
Which we use to derive these differentially expressed genes.
Right.
Yeah, but they're too many. Okay, but they're too many. Can you
So
pick?
are we able to go back to say which cell in sample 165 has upregulation of, let's say, on the 7 genes there compared to 166? Are we able to identify those particular cells in 165 that have upregulation of internal response gene?
Or those genes you use to make that GO list? Those here they are. There's 37 cells, right?
It's 37 genes.
Oh, okay.
Genes.
All right, but so
Right. These 7 genes are somewhere in these 37 genes.
Yeah.
We can also go back to the gene set library, open, like create gene set from this 65 gene gene set.
right.
But I'm not sure that's exactly what you guys want to do.
No, it's kind of simple. It should be. We want to know which B cells contributed most to that signature. You know, which of those 37
Well,
genes. You know, that
this signature is entirely, yeah. I mean, I would say this signature comes from the comparison of 165 to 166.
right.
So it's the cells in 165, these 1,500 cells, that get us to these 37 genes.
Oh, those.
Which then, those 37 genes to these targets.
Yeah.
So which?
I mean, I think what the hope was that if we then look at 165, that I mean, you know, if we have the reduced, I mean, you know, if we've reduced the dimensions in 165, then if we looked at that, you know, up in 165 versus 166, that it would be a particular cluster. I think that's the hope, you know, or if that could be done, to then look at, okay, which cells,
Yeah.
even
okay.
in 165, have this particular signature.
Sure. And that makes sense to me.
Yeah.
I think since I was having trouble just dealing with this subpopulation all on its own,
Mm-hmm.
what I'm going to do is export all of the genes for and all of the attributes associated with these 2 clusters. Actually, I'll concatenate them.
Mm-hmm.
And then I can take a closer look and try and create some dimensionally reduced parameters
Mm-hmm.
that may have islands of interest. And the way I'm understanding this is you're looking for islands distinguished between the 2 samples.
Mm-hmm. Yeah.
Okay.
Yeah.
And especially islands that contribute to those those pathways or those 37 genes. You know, those 37 genes are exactly right because they link to the right pathways. So if we can find the B cells that those are B cells that were used to make those 37 genes. I don't know, that's like the inverse, going backwards to the B cells from the 37 genes that seem to distinguish. You know, when you gate it on I guess you gate it on the ones that were upregulated in 65, 66, then those were the genes that came up. kind of like backwards mapping from the genes back to the cells. A group of genes.
Right.
It's the group
You can
of.
look at the expression within the cells.
All right.
It does depend somewhat on like which cells you want to look at it for. But I think we had looked at it in just the B cells, right? On that kind of swirly dimensionality reduction.
Right, just to be.
And it wasn't fairly clean cut.
Maybe all cells are. That's one possibility.
Yeah, but these are the ones that are up and
Yeah,
65.
but maybe all cells, just an average, that they're generally higher.
What's going on here? I think he's gonna get it. Swirl.
Whoops. Anywhere that we see these genes turned on in a particular region, I'm expecting that to be 165 cells. Those cells coming from patient 165.
Yeah.
Kind of hard to. I was thinking of like make a vector out of those genes. Some, component incorporating all of those genes, and then do a histogram of 165. For ones that express one or more of those genes. I think you just add them up, right? Yeah, I think you've done that before. This is simpler. Instead of doing something real fancy, just define those genes as a set of genes and then plot the number of cells versus that gene set and see what if there's a few cells that tend to express all those genes. Might be one or two that express all, a few that express all of them. So maybe a gene set from those 30, the gene set from those 37 genes, and plot that versus the B cells on a cell view. I don't know if that works.
Yeah. Well, like I say, these are all B cells. These are the ones we identified as CD3 positive and CD3 epsilon negative.
Oh.
And you can kind of start to see like how these gene sets work in terms of the samples. Because we define them samples, you can see that